Okay, this is notes 3.1, the chain rule. So in order to understand the chain rule, we first have to understand composition of functions. So recall, composition of functions means we are plugging one function into the other. So f of g of x. So looking at these examples, we have to be able to identify what is the outside function f and what is the inside function g. So for this one, f would be sine of x. That is the outside function. G would be x squared, because that is the inside function. For this one, f would be the square root of x, because that's the outside function, and g would be the natural log of x, which is the inside function. And then we look at this example here and notice that we don't just have two functions, but three. So this would be the same as saying f of g of h of x. So the outside function f would be cosine, the middle function g would be sine, and the most inner function h would be 5x. Okay. Which leads us to the chain rule. So the chain rule states that we first take the derivative of the outside, so that would be f prime of g of x, and then multiply it by the derivative of the outside. Sorry, the inside. So again, this is the derivative of the outside times the derivative of the inside. Notice that when I took the derivative of the outside, I still left g of x in the parentheses. So for each of these, we're not going to touch whatever is inside the parentheses when we take the derivative of our outside function f. And then when we multiply by the derivative of the inside function, that is when that inside function will ultimately change. So for example, my outside function would be x squared. And my inside function would be x squared minus 5. Sorry, x to the fourth. Okay, so outside function is this. Inside function is this. So when I take the derivative of that outside function, I'm going to bring the 4 down and then subtract 1 from the exponents. So this becomes 4 times x squared minus 5 to the third power. That's the derivative of the outside function. Notice I wrote x squared minus 5 inside the parentheses instead of leaving it as x. Then I take the derivative of g, which would be 2x. So to simplify this, this would be 8x times x squared minus 5 to the third power. That's our answer. Okay, number 2, our outside function is the square root of x. So I know I can rewrite g of x as 4x minus 3 to the 1/2 power. So when I take the derivative of the outside, this is going to be 1/2 times 4x minus 3 to the negative 1/2 power times the derivative of the inside, which is 4. So simplifying this, 1/2 times 4 is 2. So 2 divided by the square root of 4x minus 3 would be the derivative, because we are not able to leave a negative exponent in our answer. So I brought the 4x minus 3 to the denominator, and instead of writing to the 1/2 power, I know that that's the same as the square root. Okay. For this one, you're going to notice that there is 3 functions here. So we can actually rewrite this as sine of 5x squared, which means my outside function is technically x squared. So I'm going to bring the 2 down. So this is 2 sine of 5x to the power of 1. Okay. Then I take the derivative of the inside function. So that's sine of 5x. The derivative of sine is cosine, so this is cosine of 5x. And then I take the derivative of the most inside function, which is 5x, and that is going to be 5, which means h prime of x is equal to 10 sine of 5x times cosine of 5x. Okay, number 4. Number 4, our outside function is natural log, our inside function is x cubed. So that means the derivative of natural log is 1 over x, or in this case, 1 over x cubed, times the derivative of x cubed, which is 3x squared. Well, this is the same as saying 3x squared divided by x cubed, which is the same as 3 over x. That is our derivative. Okay. Number 5, go ahead and just skip it. Notice it's the same as 4. And then for number 6, real quick, there's a typo here. This is supposed to say f of t is equal to the following. Okay, so when we're taking the derivative here, we'll first take the derivative of the outside function. So that is 3 times 2t plus 1 divided by 2t minus 5 squared. And then we take the derivative of the inside function. But notice, our inside function here is using the quotient rule. And if you recall, the quotient rule is f prime g minus fg prime all over g squared. So when I multiply this out, I'm using the quotient rule for that inside function. So I'm going to get 2t times 2t minus 5 minus t squared plus 1 times 2, all divided by 2t minus 5 squared. Okay. I can simplify this to be 3 times t squared plus 1 squared over 2t minus 5 squared times 4t squared minus 10t minus 2t squared minus 2 all over 2t minus 5 squared, which gives me 3 times t squared plus 1 squared times 2t squared minus 10t minus 2 all over 2t minus 5 to the 4th power. Okay, now let's look at number 7. So number 7, notice before we get started that this is the product rule. And recall that the product rule is f prime g plus fg prime. So we're first going to take the product rule. So the derivative of 2x is 2 times 1 minus x to the 1/2 power. So I'm rewriting it in terms of the exponent. Okay. Plus 2x times 1/2 1 minus x to the negative 1/2 power. And since we have a function inside of another function, we have to use the chain rule here. And the derivative of 1 minus x is negative 1. Okay. So to simplify this, this could be 2 times the square root of 1 minus x. And then this negative 1, 1/2, and 2x is going to become negative x. And then this whole thing is going to be divided by the square root of 1 minus x. So this right here would be our derivative. Then we have to plug in negative 3. So I have 2 times the square root of 1 plus 3 minus a negative 3 over the square root of 1 plus 3. This gives me 2 times the square root of 4, which is 2. So this is 2 times 2 plus 3 over the square root of 4, which is 2, which gives us 4 plus 3 over 2, or 11 over 2. That would be our answer when we plug in negative 3 into the derivative. Okay. The next questions, we have a table. They want us to take the derivative using the chain rule for each of them, and then find f prime of 4. So for this first one, f prime of x would be equal to 2 times g of x times g prime of x. And since we want to find 4, f prime of 4 is equal to 2 times g of 4 times g prime of 4. And if I look up at the table, I'm able to see that g of 4 is 3, so this is 2 times 3. G prime of 4 is negative 2. So I have 2 times 3, which is 6. 6 times negative 2, negative 12. Okay. Then for this next one, we have f prime of x is equal to 1/2 times h of x to the negative 1/2 power times h prime of x. Because we know this is the same as saying h of x to the 1/2 power. Okay, then we're going to plug in 4. So this is 1/2 h of 4 to the negative 1/2 power times h prime of 4. So then looking at the table, h of 4 is 9. So this is 1/2 times 9 to the negative 1/2 power. And h prime of 4 is 5. So simplifying this, I have 1/2 times 1/3 times 5, which is equal to 5/6. And then last one here, f prime of x is going to be equal to h prime of g of x times g prime of x. And then f prime of 4 is equal to h prime of g of 4 times g prime of 4. Okay. So again, referring to the table, g of 4 is 3. So this is h prime of 3. And then g prime of 4 is negative 2. H prime of 3 is negative 3. So negative 3 times negative 2 is positive 6.